What is metal fabrication and what technologies exist? So let's dive into fundamental part of industrial production and engineering of it. The process is at the heart of everything from skyscrapers to smartphones. Whether you're building a bridge, a bicycle, or a high-precision mechanical part, chances are metal fabrication is involved. So, what exactly is it? How does it work and what technologies drive it today? Metal fabrication refers to the entire process of building metal structures and components by cutting, bending, welding, machining, and assembling. It transforms raw material, typically sheet metal, metal rods, or billets, into a final usable product or intermediate components used in a further assembly. It combines engineering, design, skilled labor, and cutting-edge technology to produce everything from car frames to custom enclosures, robotic arms, aerospace components, and architectural features. So let's break this down by technology and process type and go into more detail about how each one is used in the real world. Cutting technologies. Cutting is typically the first stage of fabrication, and today's cutting methods offer incredible precision and speed. Laser cutting utilizes high-powered lasers to vaporize or melt material in a fine, focused beam. It's ideal for a thin to moderate thick sheet metal and can handle complex shapes with tight tolerances. It's very common in automotive industry such as dashboards, electrical enclosures, and signage. Lasers can be CO2 based or fiber optic depending on the application. Plasma cutting uses a jet of ionized gas to melt and eject material. Faster and cheaper than laser, especially for thick steel, found in shipyards, industrial machinery manufacturing, and construction. Water jet cutting uses high pressure, water mixed, and abrasive particles to cut metal and other materials without heat. It's perfect for a heat-sensitive application like aerospace, components, medical devices, or even some exotic alloys. Mechanical cutting, shearing, sawing, punching. These traditional methods are still very common. Punch presses create holes or cutouts. Shear slice straight lines. CNC band saws cut tubing or bars. It's very efficient for a mass production of a simple part. Now we have a forming and bending. This stage gives the metal in three-dimensional shape. Press breaking. A programmable press applies force to a metal sheet across a die to create a bend. It's used for the HVAC housing, brackets, and electrical boxes. CNC press brakes allow for a high precision and repeatability. A roll forming, a continuous process for creating long profiles like rails, tracks, or beams by passing metal to rollers to gradually bending. Stamping and deep drawing. Stamping uses a press and die to form parts with a single or multiple hits. It's great for a high volume production like car doors. Deep drawing is used to form deep, hollow shapes like fire extinguishers, kitchen sinks, and cookware. Spinning and hydro forming. Metal spinning uses a platform, it's basically part of the CNC, let's call it, to form a symmetrical part like cones or cylinders. Hydroforming uses the fluid pressure to form complex shapes inside the mold. It's basically a press. Great for a lightweight automotive frames. Machining. CNC milling uses rotary cutters to remove material from a block, allowing for extremely complex geometries and tight tolerances. It's used in aerospace parts, surgical tools, and high-end automotive components. CNC turning. It basically rotates the workpiece while cutting to remove the material. It's perfect for round parts like bushings, axles, or shafts. And then we have a drilling and tapping. It adds holes or internal threads to parts. It's often combined with other machining methods. Machining is very often used after forming or welding to add the precision features that can be formed or stamped. Joining, such as welding, riveting, and fastening. Metal parts rarely stay separate. They need to be assembled. And then we have a welding for that. Welding is basically a fusion welding joins two or more metal parts by melting the base material and adding a filler. Those types include MIG welding, versatile and easy to automate, great for the automotive frames and industrial equipment. TIG welding provides clean, strong welds with a minimal spatter, used in aircraft parts, high-end bicycle frames, and stainless steel furniture. Then we have a stick welding, simple and robust, used in outdoor construction and repair. Now we have a riveting and bolting. It's used in application where disassembly may be needed, or welding might weaken the structure. Aerospace and architectural structures use rivets to avoid warping them from the heat. You probably saw that on the wings. Brazing and soldering, lower temperature joining process for a small, delicate, and dissimilar metal parts like electronics and plumbing fixtures. And now we have a finishing and surface treatment, such as powder coating, which applies a dry powder and basically baked on to form a protective, durable layer. It's super popular in consumer products like appliances, outdoor furniture, and gym equipment. We have anodizing as well. It's an electrochemical process that thickens the natural oxide layer on the aluminum, improves corrosion resistance and appearance. It's used in aerospace, architecture, and consumer electronics. We also have electroplating. It adds a thin layer of another metal, like a chrome or nickel, and improves conductivity, appearance, and of course, corrosion resistance. We have a bead or sandblasting, which basically abrasive blasting techniques is used to clean, texture, or prep metal surfaces before coating or welding. It's a cleaning procedure. And then we have automation and smart fabrication. Today, many metal fabrication processes are automated or semi-automated. For example, CNC, computer numerical control. That's basically systems that guide machines with a high precision. And then we have robotic welding. Robotic welding is used in mass production for consistent repeatable welds. You can see the big plants that are using robots for the welding and assembling, and the process is much faster than doing just the manual labor. Then we have a laser-guided systems and real-time sensors that reduce waste, improve speed, and maintain tolerances. AI and digital twins are being integrated into fabrication workflows for predictive maintenance, optimization, and real-time quality control. Application and some examples for that in the automotive industry is everything from frames to brackets to dashboards. High-strength steels are formed and welded with a precision. In the construction, you have beams, frames, structural panels, staircases, and bridges. In aerospace, we have a lightweight, corrosion-resistant alloys that are machined and joined with amazing precision. In the consumer goods, metal cabinets, appliances, and gym equipment, as well as some electronics. Industrial equipment are fabricated housing, machine enclosures, tanks, and control panels. Choosing the right fabrication method matters, and the right process depends on volume, tolerance and geometry, and definitely budget and the speed. And we should not forget the finish and material. It's really important that you choose the right process for your project. And Xprop, we can help you choose the right approach based on your product needs even before design begun, as we want to create your product towards certain technology to save you money. From concept sketches to high volume production, we work with certified fabrication partners. We also have manufacturing facility to ensure quality and consistency at every step. Whether you're building a prototype or scaling to thousands of units, understanding the power and flexibility of metal fabrication is a key. It's more than just cutting and welding. It's the art and science of turning metal into innovation.